Here are your solutions to 5-5. These, of course, are the letter problems. We'll start with letter A. Remember that our generic formula is that a squared plus b squared must equal c squared for the Pythagorean theorem. And we can always look at our legs as the a's and the b's. So if you'd like to, it wouldn't be a bad idea to label these a and b. And this, of course, has to be c. But in a way, they already did that when they give you the unknown as a letter. So I'm going to leave it at that. So in the first one, we have 24 squared plus 18 squared equals c squared. 24 squared is 576 plus 18 squared is 324, and that equals c squared. So we've got 324 plus 576, and that equals 900. Nice round number, equals c squared. Take the square root of both sides, and we have 30 equals c. So for letter A, our solution is 30. We go back here and we see that we're talking about yards, so we have 30 yards. Letter B, we have a hypotenuse, so we're going to say that b squared plus 3 squared is the other leg equals 8 squared. So we have b squared plus 9 equals 64. Subtract 9 from both sides. We have a 0 pair, and we have b squared equals 64 minus 9 would be 55. So now we have b squared equals 55. We take the square root of both sides, and we end up with b equals the square root of 55. And the square root of 55, I'm going to write that down here. The square root of 55 is 7.41619. I don't need to carry it out anywhere near that far, but remember, we're talking about rounding to the nearest tenth. So the answer for letter B will be 7.4. And we go back to our unit, which is right here, 7.4 miles. And lastly, we have letter C. In this case, we're given the one leg and one hypotenuse, and we're looking for A. So we're going to go a squared plus the leg is 17 squared equals 20 squared. So we have a squared plus 17 squared, and 17 squared is 289 equals 20 squared. That's easy enough. That's 400. So again, we're going to subtract 289 from both sides, and we end up with an a squared. This, remember, is a 0 pair, equals 400 minus 289, and that equals 111. We need to take the square root of both sides, and in this case, we'll write the number way over here. It's 10.53565, but we're not going to use all that. We're going to round to this digit here, which tells us that our answer is 10.5, and here we're looking at centimeters. So there are your three answers for problems A through C, and the math for each individual situation. Okay, now we're going to work on letters D and E. In this case, we are using the converse of the Pythagorean theorem, remember, and we're going to see if the first two legs squared, if the sum of those two squares equals the sum of this squared. So in this case, for letter D, we have 30. We're checking, we're asking ourselves, is 36 squared plus 48 squared, does that equal 60 squared? Well, we can square this one in our head. That's easy, 3600, because we should have two zeros. So now we've got 36 squared is 1,296 plus 48 squared, which is 2,304. Add those two together, and we do indeed get 3,600 does equal 3,600. So determine whether each triangle with sides of given lengths is a right triangle and justify your answer. And here's how you justify that answer in this case. You would say that the answer is yes in this case, and you would say that 36 squared plus 48 squared does equal 60 squared. Or you could say that 3,600 equals 3,600. There's more than one way to do that justification. The key here is that you recognize that indeed it is yes. Now for problem number 4, we have our two smaller legs. Notice we didn't do this in order in this case. Our two smaller legs are 4 and 5. So we're asking, does 4 squared plus 5 squared equal 7 squared? And this one we can do quite easily in our head. We have 16 plus 25. Does that equal 49? And now our justification here is going to be easier to do because you can see that this is 6 plus 5 is 11, 2 plus 1 is 3, plus the one additional would be 49. And notice I put a line through this, so we would say no in this case, and we would say it is no because 41 does not equal 49. Or you could say that 4 squared plus 5 squared does not equal 7 squared. Please do guided practice. Okay, problem number 1. Write an equation you could use to find the length of the missing side of each right triangle, then find the missing length round to the nearest tenth if necessary. So because we're looking for the hypotenuse, which is across from the right angle, we're going to say that 16 squared plus 12 squared equals c squared. So 16 squared is 256 plus 12 squared is 144, and we're going to say that that equals c squared. So we have 256 plus 144, and that equals a nice round number of 400 equals c squared. We're going to take the square root of those two, and the square root of 400 is 20, so 20 equals c, and in this great case that means meters right there, so it's 20 meters. Now let's try number 2. In this case, we're also looking for c. So we are going to look at it right here. We have 100 squared plus 200 squared equals c squared. So 100 squared would be 1 with 4 zeros behind it, plus 200 squared would be 4 with 4 zeros behind it. So it would be 10,000 and 40,000 equals c squared. So that would be 50,000 equals c squared. Take the square root of those two, and we get 223.6, and it's 0.606. So we can round to the 6, and you can see here that we're in millimeters. So there's two answers for problems 1 and 2. Now let's take a look at 3 and 4. 3 and 4 say determine whether or not we have a right triangle, and of course that justify your answer. So we take our two smaller legs, so we have 5 squared plus 10 squared, and we're asking ourselves, does that equal 12 squared? Well, 5 squared is 25, 10 squared is 100, so that's 125. And we're asking ourselves, does that equal 12 squared? Well, that's 144. So the answer is a clear, easy no, it does not. And our justification, so we could say no, and our justification is that 125 does not equal 144. Problem number 4. Our two smaller legs are 9 and 40. So we are asking ourselves 9 squared plus 40 squared. Does that equal 41 squared? So 9 squared is 9 times 9 is 81, plus 40 times 40 is 1600. Does that equal 41 squared? And 41 squared is 1,681, and you can see this right away that this is indeed 1,681 as well. So we would say yes. And we could say this one of two ways. You could see 1,681 equals 1,681, or you could say, like we have it up here, that 9 squared plus 40 squared does equal 41 squared. either one. And lastly, let's look at our essential question. Building on the essential question, what is the relationship among the legs and the hypotenuse of a right triangle? And it's simply, that is what the Pythagorean theorem is all about. It's the sum of the square of the lengths of the legs is equal to the square of the length of the hypotenuse. Remember to know, to be able to recognize legs versus hypotenuse. In this case, I drew the legs in red and the hypotenuse in blue. The sum of the square of the legs must equal the square of the hypotenuse. Please do independent practice.